So in Chapter 4, we're going to talk about chemical quantities and aqueous reactions. This chapter starts out with a little bit about the greenhouse effect, and global warming. I'm not going to test you on this, but I'm just going to talk about it briefly because I think it helps us to make connections between real life and what we're learning about in chemistry. So greenhouse gases in the atmosphere allow sunlight to penetrate through. The sunlight warms the Earth's atmosphere. That heat energy then starts to move away from the Earth, and the greenhouse gases trap some of that heat and keep it from escaping. So in order for our planet to be habitable, we need a balance. We need to have enough energy coming in and being trapped, but not too much. So there is concern that we're experiencing global warming. Scientists have measured an average 0.7 degrees Celsius rise in atmospheric temperature since 1860. Now, whether that is a significant temperature increase or not is something that can be debated. So here is a graph showing average global temperature in degrees Celsius, deviation from the baseline. I never actually looked at that. It's the temperature deviation. We've also been measuring atmospheric carbon dioxide. And you may wonder, well, how do we even know what the atmospheric carbon dioxide was back in 1860? Well, some of these measurements are not direct measurements. They are inferred from things like, size of tree rings and various things. Yes?
Is the greenhouse gases, is that referring to like the ozone layer?
Greenhouse gases, is that the ozone layer? I think the ozone is part of the greenhouse gases. Yeah. So if we look at the same time period in atmospheric carbon dioxide, we see that there's been an increase. How you draw this graph can make it look more or less alarming. Okay, so this is a 38% increase. That's a significant increase, but maybe not as scary as this looks. This is going from 270 up to 400. If you started at 0 here, then the line would not be as steep, right? One thing I'd like you to come away from Chem 1A with is an understanding that data can be twisted. Data can be used in ways that maybe are not appropriate to promote someone's political agenda or business agenda or whatever. And so we need to have ways of looking at the numbers that take that bias out of what we want to see in the numbers. Well, where's all this CO2 coming from? I forgot to mention. So there seems to be a correlation here. Atmospheric carbon dioxide has gone up, global temperature has gone up. That does not mean that the trends are causal, meaning that one is causing the other. It could be true, but not necessarily. Where's the CO2 coming from? Well, combustion of fossil fuels is one source of CO2. And we can represent that with the chemical equation for the combustion of octane. Octane reacts with oxygen, it forms carbon dioxide and water. So that's a source of carbon dioxide. Another source of carbon dioxide is volcanic action. Volcanoes are giving off CO2 into the atmosphere. So how can we judge whether global warming is natural or due to our use of fossil fuels? Well, we could look at how much CO2 is coming from each of these sources, right?